Um, Hello everyone. Welcome back to MAC1140 pre-calculus. So last time we learned polynomial function, and we learned that polynomial function can be written in two forms: a standard form and a factoring form. In many situations, if polynomial function is not written in factoring form, then it's very hard for you to find the zero of the function. I mean, it's very hard for you to find the intersection between the graph and the x-axis. So in this section 4.2, we learn how to use a method to first of all, to simplify the polynomial to do division. No, I'm sorry. A method of putting polynomial function in a factoring form by doing division. We call it long division and syntactic division. Other than that, in this section, you guys also introduced to one of the very great French mathematician named Bezout. He developed two important theorems in pre-calculus. The first theorem we call the Remainder Theorem, and the second one we called factor graph theorem. Okay. But before we can jump to those theorems, let's start our lecture today with division algorithm to do long division. Okay. So let's get started. 4.2. Theory of polynomial function. I don't know, it's kind of too bright for you. I don't know how I'm going to change it though. So we'll try like that. Okay. So let's start our lecture by learning division in polynomial function. So division in polynomial. This division is kind of similar to the very elementary division you already learned elementary school, the basic one. The division is based on an algorithm we call Euclidean algorithm. Euclidean algorithm. In the textbook, some textbook we call that division algorithm. Now, back in the day when you learn division, right? For example, you divide 3 by 2, 2 go into 3, right? So like this. Then how many times? You 1 time, right? Then you multiply them back, give you 2, and you do subtraction, give you 1 left. The number 1 right here, we call that remainder. Okay. The number 1 up here is called quotient. Number 2 right here, we call what? We call divisor. And number 3 here, we call dividend. Okay. So when you do a division for polynomial, you're gonna use the same strategy. You will have a dividend, divisor. The remainder could be 0 or something, or the remainder could be another polynomial function. And we also have quotient. And all of that is based on the Euclidean algorithm called the division algorithm. And this algorithm is that if we have f of x, okay, and we divide it by I'm going to just say d of x. Okay. Okay. And if we have a remainder and we have quotient, then this will multiply by the quotient, which is q of x. Okay. Then we can add the remainder plus r of x. Okay. So r of x over here is the remainder polynomial. Okay. Q of x is the quotient, d of x is the divisor, and f of x is dividend. Okay, so this is divisor, and this is quotient. Okay, and what I have over here, I call the Euclidean algorithm, or sometimes we call division algorithm. Okay, okay, okay. So let's start with our first example here, so that you can see it, you can understand better how it works in when we deal with polynomial division. What if I want to divide 3x to the 4 plus 2x to the third power? Okay, plus 4x squared plus x minus 5, and you divide it by x squared plus 2. So x squared plus 2 is actually the divisor. 3x to the 4, 2x to the third, 4x squared plus x minus 5 is the dividend. Okay, and we're going to set up the same way as we set up with the basic division we learned in elementary school. Okay, so we're going to have a divisor, okay, x squared, but you see that this is a second degree and this is a constant term, so it means what? It means that there's something between the second degree and the constant term is the first degree, so 0x, right? Even though it's not there, but it's invisible because it's 0 plus 2, and you divide it by, okay. Let me check this dividend polynomial is a full one or not. To go to the to start with the 4th degree, then we jump to the 3rd degree, second, the first, and the 0. So look like this is good. And we have to put everything in order. So let's start with the 4th degree, then the 3rd, then the 2nd, the 1st, and final we have constant. Okay. All right. So let's just start with the division. Okay, so x squared go to 4x to the 4. So what we're gonna have, we have 3x squared, right? I multiply them back. So I have 3x to the 4 plus 0x to the third plus 3x 3 times 2 6x squared. Okay, then you do division. Then you subtract 0 plus 2x to the third plus 10x squared plus x. Now we drop x down. Okay, and you can do division like that. X squared going to 2x to the third, so you 2x. 2x times x squared is 2x to the third. 2x times 0x is 0x squared. 2x times 2 is 4x. Okay, and you start subtraction again. So you have 0. You have 10x squared. Oh, let me see. Oh, this is not. This one look like this is -2. I'm sorry, because 4 minus 6 is -2. So this is to give you -2x, right? And give you -3x. Okay. What else? Now we keep doing division. Okay. So x squared going to -2, so give you -2. Okay. -2 times x squared is -2x squared minus plus 0 minus 0x minus 4. do subtraction. So all of this step you already learned in college algebra. Okay, so I'm not going in detail too much. Just turn out to be 0 and minus 3x. Oh, again, I forgot top number here. So minus, so you negative 1. Okay, and now this is the degree is second degree, and this is the first degree. We cannot go anymore. So it means what? It means that negative 3x minus 1 is the remainder. Okay, then we're gonna have like this. We're gonna have the dividend. And we can write the final answer using the Euclidean algorithm. X squared plus x minus 5 equal divisor x squared plus 2 times quotient 3x squared plus 2x minus 2, and you add to the remainder plus negative 3x minus 1. Okay, and there's another way to write it. You can write like this. This is also equal to 3x squared plus 2x minus 2. Okay, 3x to the 4 plus 3x cubed plus 4x squared plus x minus 5. When you divide it by x squared plus 2, then you have quotient plus the remainder over x squared. Okay. So there's two different ways to write your final answer. Actually, in this way, in this second way right here is also based on Euclidean algorithm. So it's kind of the same. So it's up to you to write your choice. So you can write which one you prefer. You can write like this, or you can write. All right. Again, this is we already learned in college algebra. We call this long division. Okay, I think I'm going to put over here long division. Another method of doing division, okay, is called syntactic division. For a syntactic division, you have to use the coefficient of each term in polynomial. Okay, and the divisor must be in the form x minus c. So the divisor right here, you see that for long division, the divisor is like x squared. You know, could be anything, as long as the highest degree is smaller than the highest degree of the dividend. However, for syntactic division, the divisor must be in this form. If it's not in this form, then you cannot do syntactic division. Okay. For example, I have negative 10x squared plus 2x to the third minus 5, and I want to do division by x minus 4. So you see our divisor right here is x minus 4, which is in the form x minus c. C is 4. Okay, c is 4. Yes, and you see that our dividend function right here, polynomial function, is the third degree, but it's not in the full form. You see, they missed the first degree one. They start with the third one, they jump to the second, then they should jump to the first one, then finally they got a constant. But in this case, they missed the first degree constant, the first degree term, and it's not in order, so I have to reorder them. See, for the first degree, it's not there, so I'm going to put 0x. Okay. All right. And what next? After you reorder, and after you add the invisible term right there, you're going to set up the syntactic division. I mean, you do the same when you do long division. You know, if it's not in order, you have to reorder. Okay. So to set up syntactic division, the C value in this case is 4. It's very important. You're going to put 4 like this. And you're going to write out all the coefficient of each term, which is 2, -10, 0, okay. Then you're going to draw the line like this. And you can always drop down number 2, which is the first coefficient. And 4 times 2, then you take 4, you multiply by 2. Okay, give you 8, add them up, give you -2. 4 times -2, -8, add them up, give you -8. 4 times -8 is -32, add them up, give you -37. Okay. The last number here, we call it remainder. Okay. If the last digit, the last number is 0, then means the remainder is 0. But in this case, the remainder is -37. So we have the remainder. But you know, some students are very confused, and you know, they don't know which one is the remainder. I mean, usually, it must be the last one, right? And because you look at this, this is the third degree. When you divide by the first one, right? You divide by the first one, which is in this case x. Okay, it's always the second degree, right? And the second degree has 3 terms. So our quotient here, is 2x squared minus 2x minus 8. So this is quotient. Okay. Then I can use Euclidean algorithm to write final answer. So I can write like this: 2x to the third minus 10x squared minus y will be divided by x minus 4. Then you will have what? You will have quotient, right? 2x squared minus 2x minus 8. And you have remainder, which is -7 on the top, and x minus 4 divided by 5. Okay, so this is quotient. It's remainder right here. Okay. Some students find it hard to write the quotient in polynomial form. Just think about it. You don't know like what degree you should start for the quotient. Very easy. Okay, the original question is the third one, and the divisor polynomial function is the first one. The third one divided by the first one, it must give you the second degree. So you have to start with the second degree. And you start with the second degree, you jump down by 1 degree, and you have the first degree, right? Then you jump down and you have 0 degree, which is only constant. All right. So that is how you do syntactic division. Another interesting thing in this syntactic division is that the remainder number and the C value has a very close relation to each other. And Bézout is a French mathematician. He found out that the remainder number and the value C, it kind of has something related to each other. And actually, he found out that the remainder is actually the output. The remainder is actually the output of polynomial function and given C as the input. Okay, so that's why he can come up with a theorem. We call that remainder theorem. So the second part, I want to talk about remainder theorem. And Bezut successfully proven that f of the remainder, f of r, or f of c, I'm sorry, f of c, f of the number c right here is equal to r. So you see the remainder here is actually the output given c as the input. Okay. F is original, this is the dividend polynomial. So this is dividend polynomial. Okay. C is input and R is the output. Okay. So if F is divided by x minus C, then F of C equal R. So the whole theorem is if a poly fx is divided by x minus C, then f of C equal R. So that's the remainder theorem. Okay. For example, let's look at this example here. So I can write that f of 4 equal to negative 37. And f in this case, what f in this case is this. F in this case is 2x to the third minus 10x squared minus 5. So that's fx. Okay, fx is 2x to the third minus 10x squared minus 5. Okay. If you don't believe, you just go ahead and look for, and I know that it turned out to be negative 37. Okay. I can give you another example. Given fx equal to x to the 4 plus 6x to the third minus 12x squared minus 30x plus 35. It look like our dividend is in full standard form. It does not miss any term in between. Use remainder theorem. Okay. To evaluate f2 and f negative. Okay. So they want us to evaluate fx equal to. Okay. X equal 2. It means that x minus 2. Okay. It means x minus 2 is divisor. It means your c. It means your c is 2. C equal 2. Now let's start with our syntactic division. 2, 4, 6, negative 12, negative 30, 35. Okay. Up and down. 2, 8, 16, 4, 12, 18, 36, negative 1. All right. So look at that. You have the 4th degree. You divide by the 1st degree. Then this one right here, the quotient, must start with the 3rd degree. So the quotient must be x to the third, that's ax squared minus 4x minus 18. And the remainder is -1. And if the remainder is -1, by using the remainder theorem, I can write f of 2 equal -1. Okay. Similarly, I can evaluate at x equal to -7. It means x plus 7 is divided. Okay. And this means c is -7. C is -7, right? Okay. And you set up the same thing, -7, 1, 6, -12, -30, 35. Round it out. 1, 8, -4, 28, -2, 49. Okay. Oh, 14. Right. Did it say anything? 6. 1. Oh, 37. Sorry. So -5 is 35. So you find here is -35, so 0. Okay. So over here the remainder is 0. Okay. Okay. So it means what? It means f of -7 is 0. According to our remainder theorem. Okay. Every time we have a remainder theorem as 0, it's very interesting. Actually, Bezout, he come up with another theorem, and he said that every time you do syntactic revision and the remainder is 0, it means what? It means that x, it means x plus 7 here is the factor. Is the factor of fx. Okay, so if you do division, syntactic division by a c number, and if the remainder is 0, then x minus c is called the factor of polynomial function fx. Okay, right. So actually that's come from a theorem called factor theorem. Okay, let me write out for you what the factor theorem is. Here. A factor theorem is stated again by Bezout, and he said that if fx a polynomial function, okay, and if f of c equals 0, then x minus c is a factor. Okay, all right, x minus c must be factor. You know, when I say x minus c is factor, you know right away, your fx polynomial function can be written as x minus c times something, because every time you talk about factoring, we talk about multiplication, right? Okay. So they could have more factor. Fx could have more factor, but the factor theorem just say that if it f of c equals 0, then x minus c must be. Okay. For example, use factor theorem to determine if the given polynomial is factor of fx equal x to the 4 minus x to the 3rd minus 11x squared plus 11x plus 12. All right. Okay. So how are we going to do that? We just need to show. Oh, I'm sorry. Use a factor to determine given. I have give you the polynomial. So the first polynomial is x minus 3, and the second one is x plus 2. So they ask you to check if x minus 3 is a factor of this or not. Okay. If it is a factor of this, it means what? It means that f of 3 must be 0. Right? F of 3 must be 0. Okay. But how we show f of 3 equals 0? Okay, we just do synthetic division. Yeah? So I just do synthetic division. 1, then 1, then 11, 11, 12. 1, 3, 2, 6, negative 5, negative 15, negative 4, negative 12, 0. So I just show that f of 3 equals 0. And if f of 3 equals 0, then look at that. Then x minus 3 must be the factor of f. Right? According to factor theorem. According to factor theorem. All right. You do the same over here. Okay. But what number we should do division for? By? It must be number -2, not 2, because over here the theorem say x minus. Okay, but we have x plus, so we should do synthetic division by -2. So -2. Okay. All right. So we drop them down. 2 here, 3, 6, 5, 10. Right. So the 2, -44. Okay, add them up to give you -32. And this is the last digit, the last number, I'm sorry, is -32, and it's not 0, right? Then we have what? According to our remainder theorem, we can write f of -2 equal to -32, and it's not 0. Oh, I'm sorry. Okay. It is not 0. And if it is not 0, then I can conclude x minus -2, right? Will be +2. Okay, is not a factor. Okay. So in order to check a number is a factor, you just do syntactic division. After you do syntactic division, you check the remainder. If it turns out to be 0, then f of that number equal to 0, and according to factor theorem, that must be factor x minus that number must be the factor of polynomial function. Okay. So that is the most two important theorems in this section. On section 4.3, you will be introduced to two greatest mathematician again, and not Bazut anymore. You will be introduced to Gauss theorem, and you will be introduced to Descartes theorem. Okay, we will learn how to find the number of 0 the intersection point between the graph and polynomial function, the graph of polynomial function and the x-axis. But in this section, that's all we have. Okay. If you look at it, you will see that the concept is you already learned in college algebra. Okay. And maybe in college algebra, the professor did not go deeply into factorial theorem and remainder theorem. But in this course, we should be focusing on those theorem, and most of the question will be based on this theorem. Okay. So if you don't understand, please go ahead and let me know. Send me a campus message. Keep working on homework. Then I will be seeing you next time. Bye bye.